Good morning, friends. It gives me immense pleasure to be here again for my course, which is Aircraft Systems. Today, I am in the topic, a case study on avionics and mission systems. As you know, I am Dr. Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. As of now, I have completed my all 5 modules of aircraft systems. If you talk about the modules, in first module we have introduction to aircraft systems. In that we are giving all basics of different aircraft systems like airframe or structural system, vehicle system, avionics system and the mission system. If you talk about the airframe system, in that we have fuselage, we have wings, we have empennage, we have landing gears, we have engine pylons and so many parts are there, and in detail we have discussed in module 1. In module 2 we have the electrical system, power generation system, power distribution system, power connection system, bus bar systems, different generators, modern power systems like 270 volt DC, and most of these things I have already covered in this problem solving and the case study also. For power systems I have done it. I have also discussed in module 3 about hydraulic systems and the pneumatic system. In next module we have avionics and the mission system. Today I am going to discuss much detail about avionics systems and mission systems used in aircraft. I am going to discuss in detail about avionics and the mission system. So if I talk about what is avionics, avionics word comes from the 2 words aviation and electronics. If you join this thing, it becomes avionics. So the electronics which is used for aircraft, aerospace, missiles, helicopters or any other aviation machines, we say that the component, that electronics which is used for this aerospace purpose is called the avionics. So mostly in avionics we can divide into 2 main groups. First one is the navigation system, another is the communication system, and between these two there is an interface which is the computers. So we have nowadays modern computers which are used for the avionics interfacing of the systems. Next, if you talk about the mission system is especially designed for the military aircraft, and in military aircrafts can be designed for different missions. Like if you see the Indian Navy, in the Indian Navy, the aircrafts, we have the fighter aircrafts, we have the helicopters, we have different types of aircrafts which is to be on board ships. Like our Sea Harrier aircraft, now MiG-29s, they are on board Vikramaditya. Before that, Sea Harrier, it was in INS Virat and INS Vikrant. These Sea Harriers were vertical takeoff, VTOL and STOL. So it can take off and land vertically on board aircraft carriers. Also, we have some helicopters. In Indian Navy, we have the Chetak helicopters, we have the Sea King helicopters, we have the Kamo helicopters, we have the Dhruv helicopters, and so many other helicopters are there. These helicopters are positioned on board ship. They have necessary hangar there, and the purpose of these helicopters are multi-dimensional. It can carry the reconnaissance role, it can carry the surveillance role, it can also carry the anti-submarine warfare. It can detect the submarine, it can also carry the missiles, it can also carry the torpedoes and so many other bombs and other ammunitions. So, same way, if you talk about some other reconnaissance aircraft of Indian Navy, we were having Tu-142M. These aircrafts were very huge aircraft, and they can patrol all over our Indian coast, and they can detect the submarine, and also they can hit or they can kill the submarine or the aircraft which is not belongs to us, or any enemy submarine or the ships can be destroyed, also detected and destroyed. So it is called the surveillance and the reconnaissance. Surveillance and the reconnaissance. So first you do the surveillance, means go and do the find out and then recognize that where is the location. And if you find out that this is not belongs to our defense forces, then you have to do proper action, and this aircraft missile can be launched, and this air to water, air to underwater missiles are there, and this can be used, and the missile, this submarine can be killed. Like Sea Harrier also, it can carry the Magic Matra and some other missiles, and Sea Eagle missile, like these type of equipments, and they can be fired from 200 to 300 kilometers away from the target. So these are the few missions which I am telling. If you see about the other activities like normal for flood relief, for this firefighting, for earthquake relief, any busting of the sky, like our in Kedarnath, Badrinath, in Uttarakhand, some 8-9 years back, it has happened. And so everywhere our defense forces are used, and these forces are operating some aircraft to carry the luggage, carry the medicines, carry the passengers, carry the big equipments from one place to another place, and these can be coordinated with our relief forces. So like this, different missions are there, and how these missions are performed by using some type of sensors. So these sensors I will be discussing in due course of time in this lecture. So topics and the CO's mapping. Here we have the topics. First one is avionics system. Then we have the flight display system, next gen display system, mission systems, and the different sensors. So avionics systems and the display. Just what are the display? You see that as and when the pilot is sitting on board the cockpit, he or she has to see a lot of equipments. These equipments, if you see the olden time, that time it was the different, and now it is different. If you see here, this is the aircraft, and this is the Indian Airlines. I have taken a emblem of that, and this is the fuselage. These are the wings. These are the vertical fin. These are the horizontal tail. In vertical fin we have the rudder. In horizontal tail we have the elevator. In the wing we have the ailerons, both the side. Then we have the flap. Here is the fuselage. Here all the passengers are sitting, and the front door, this you can see here, and this is here. This is the cockpit. In this cockpit, one pilot is in the left side, another is in the right side. One is the captain, another is the first pilot. So two pilots are sitting. Both pilots will have the same type of instrument in their front. So they need not to depend upon each other. Every equipment which the first pilot is having, same thing, same equipments, the captain of the aircraft will also have. The control also, most of the controls are the same, except engine control. Engine controls are common for the both, and these are placed in between both the pilot. But other controls, your rolling, yawing, pitching, slats, secondary controls, all these controls, spoilers, these all things are separate for both the pilot. So as and when they have to give the charge to another pilot, and this will work. So these displays, they are very important to see that all the parameters are as per the requirement, and mostly they are in this front part. These are the cockpit glasses from where they can see the runway and some view of outside. But below this whole area, behind this, you will see lot of hundreds of equipments, measuring equipments. There are meters are placed. So this display I am going to discuss, and their evaluation, how these things have been developed by passing of the time. So this is the avionics system, and how these things are displayed on the cockpit. This I am going to discuss. So here if you see, we have the at this 1970s, a lot of industrial revolution and technological revolution has taken place. So if you see here the right side and the left side, here we have 3 crew members. Previously, before this, there used to be 3 crew members. Even I have seen the 5 to 6 to 7 in Tu-142. We have 7 crew members, 2 pilot, 1 flight engineer, 1 observer, 1 gunner, like this. So there used to be 7 crew members, they used to operate. But as of now, if you see all the modern aircrafts, there most of the time they have only 2 pilots now. Previously there used to be 3 pilots, 2 pilots, 1 flight engineer. So now this thing has been reduced due to the display system. In this zone, if you see, cathode ray tube CRT were used. Now if you see, it is active matrix LCD, it is called AMLCD. Active matrix LCD are used. 2 crew members. Here we have electronic centralized aircraft monitor. It is called ECAM. Electronic centralized aircraft monitor. Then we have EICAS, engine indicating and crew alerting system. EICAS. So these are the engine indicating and crew alerting systems. These systems are used for this purpose. So this we can divide into 2 groups, like this, old, and this is the modern. Modern displays. And this has happened slowly after 1970. Before 1970 aircraft and after 1970, a lot of things are changed, and these things are shown here, that nowadays we have AMLCD, we have the EICAS, engine indicating and the crew alerting system. We have electronic centralized aircraft monitor. So in place of different 2, only 1 monitor is there. Both the pilot can observe. It is not necessary that both pilots should have different display system. Avionics system display. Here I am showing the historical. Okay, so here this is the historical evolution of display of aircraft cockpit. So how this thing has been developed? Flight display system. Here this we can divide into 3 eras. One is electromagnetic era, second one is electro-optical era, then next generation flight displays. So we are now, presently we are here. Okay, so electromagnetic era, in this we can start with 1918, then 1929 up to 1970. This era was very much powerful, and here electric and magnetic effects were used. From 1970 to 2000, year 2000 and nearby. It is not exactly 2000. It may be 4-5 years plus or minus. Electro-optical years came. 1970s, then 1980 to 1990s, some more development, and then 1990 to 2000 and early 2000. Electro-optical era was very much dominant. Now we have the next generation flight display. We are presently in this, and here very nice and very powerful, very safe systems, very pleasant displays are there. It looks also, their appearance also very good, and their functioning also very good and accurate. So now we are in the age of next gen flight display. Here I want to say the first generation, where our electromagnetic era before 1970. So here this you can see embryonic primary flight display. Initially it was like this, very black and white type of things, very simple. In 1918, first primary flight display. Primary flight display. This is the primary flight display. It is shown here. Contains every instrument. In this, all the instruments are there. Legs, compass. In this, compass was not there. So here, what are the equipments? This you can see very time. It is a chronometer here. Airspeed, barometric airspeed is here. Engine RPM is this one. This is the engine RPM. This is the barometric airspeed indicator. Here we have inclinometer. Aircraft, how much it is banked. This you can find out from here. It will give some degree, very simple. Then we have here barometric altimeter is here. This will show the how much height. Altimeter means how much height from the sea level. It will show here a rate of climb indicator. Just you can see it is just like a thermometer. It is here, and it will indicate that how much per second rate of climb and descent pitch axis it will show. And here is the time. If you see here, this is the pressure datum setting. This equipment, it is shown in a bigger way here. Only 1, 2, 3, 4, 5, 6 equipments are here. That is why this is also called the 6 packs. 6 packs. Every aircraft will have this 6 packs. Okay, so here we have the pressure datum set as per your airport, where you want to measure your height. You have to adjust here. Accordingly, it will be adjusted, and it will show the height of the aircraft as per the requirement. So this a very basic first generation or initially setup of the displays. Now we are displaying the first generation. Further little improvement is it is also called the blind flying technique. Lieutenant James Dwivedhi, the first person who has used this thing. Gyroscopic instrument plus radio navigation aids. In this, gyroscopic instruments and the radio navigation aids were used. Uses Coleman's precision altimeter, Sperry gyroscopic artificial horizon. So if you see here, little improvement, this you can see here. Here aircraft is 20 degree left wing down. So if it is falling like this, here, this is the equipment here. It will show that aircraft is banking. Okay, just I am discussing about this equipment. So if aircraft is flying like this, and aircraft is bank. So this equipment here, this will show this much angle. This is the 20 degree. If it is 20 degree, here you will see the 20 degree. So you will be able to see like this. If it is in the right side, it will give like this. So model aircraft banks horizontal fixed to aircraft. This line is fixed to the aircraft, and this will show your aircraft, how much it is banking. So here inside looking out and outside looking out. So if you see from inside, it will look like this. If you see from the outside, it will look like this. Here is Coleman's precision altimeter is here. Coleman's the first person who has made this altimeter. And also we have the radio beam indicator. It is a radio equipment which shows the navigation path of the aircraft. And Sperry artificial horizon. This you can see, it is an artificial horizon. This both are the artificial horizon here, and it will indicate you in this way. So these are the two person, they have developed this artificial horizon. Sperry is the name of that person, and next one is the Coleman precision altimeter. These are the two new development in further aircraft display systems. Now, if you see here, we have avionics system display, and here this you can see different displays which I have shown you. Engine instruments, lot of instruments, this you can see here. So basic T sets of primary flight instruments here. Autopilot control panel is here. This is the autopilot control panel. I will write APC. And these are the engine instruments. So what are the engine instruments? Engine RPM, engine oil pressure, engine oil temperature, engine exhaust temperature, inlet temperature, inlet pressure, inlet velocity, exhaust pressure, exhaust velocity, exhaust temperature. Even in between also T1, T2, T3 different temperatures are there. And here if you see the Boeing 737, you will have same type of features. Here the flight engineers is sitting, it is called FE. Here it will be monitoring all, especially the engine parameters are monitored. Only here you have very few equipments, but if you see in this panel, there are 10 times equipments are here. Only the required things are with the pilot and remaining things are here with the flight engineer. If you see here, airspeed indicator is called ASI. Attitude indicator, your attitude of the aircraft means rolling, pitching, yawing. All this is called attitude of the aircraft. Attitude indicator is here, and this is the horizontal situation indicator, HSI. So this HSI also used in this generation of the aircraft. So now I will talk about the second generation. So now we have 1970 and nearly 80, but after that the few development has taken place, and now the system has been developed. So it is now the second generation. In second generation, we have some specific type of new technology which was not before. I think this you can see this screen. This screen shows some displays, not like equipment one instruments. There are different instruments. I will start from one side. Okay, horizontal situation indicator. This is electronic horizontal situation indicator. This one. Okay. Next, it is the EADI, electronic attitude director indicator. What is this? This is the electronic attitude director indicator. Okay. EADI. EHSI, electronic horizontal situation indicator. Next we have the ASI. This is speed indicator here. Then altitude indicator here. Altitude indicator. Then standard altitude inertial navigation system here. Inertial. Engine displays all these engine parameters which you have seen before. In this you can see there are hundreds of equipments here. So many things. This can be reduced to a small engine display. Then here we have the system displays. All the systems will be visible here. Your pneumatic system, hydraulic system, electronic systems, refrigeration system, cooling system, oil system, environmental system, pneumatic system, electrical system, all things will be visible in this. A small display. And here also if you see a full display is visible here. So in this way, the second generation has been lot of development, and it is 50% of the equipments are reduced. The size of the cockpit is very clear now. It is not just like before. It is now, if you see this one, how complicated. So much equipments are here. From here to here, if you see, full of equipments. If you see here also, huge, these all things can be avoided by small displays. And this you can see, one pilot is here, another pilot is here. Okay, so in this way, there's engine indicating and the crew alerting system. EICAS is what? It is engine indicating and crew alerting system. Next we have EADI, electronic attitude director indicator. EHSI, electronic horizontal situation indicator. Okay. Now we have the avionics system display, the second generation now. Okay, very nice equipments have come now. Second generation display. So clean. Just you can see here, so nice and so beautiful. All the things are here. Here we have the side stick. Here pilot will just have switches here and they can move left, right, forward and the rear. This one. Next we have the primary flight display. It is called PFD. Primary flight display. This part is a primary flight display. Then we have here navigation display, ND. This second one is this one. Navigation. It means the aircraft direction, aircraft positioning, its reference lines, all the things are visible in this navigation display. Then here we have the integrated standby instruments, ISIS, integrated standby instruments. Here, small, this one. Then we have the electronic centralized aircraft monitor, ECAM display. Here you will have all this engine and the system, all the things are visible here. Same way, this one is also same as this one. This is the first and this is the second. Both sides are same and these things are common. This yellow is a common and this is for the electronic centralized aircraft monitor. It contains engine parameters, it contains the system parameters. Here if you see, this is the throttle of this thing, engine, one engine and two engine, and this it will be seen here, all the things. If you see the next, it is the MFD here. This part, it is shown in a bigger way, zoomed way. So here, if you can see here, I will start from speed, LNAV, VNAV, autopilot enunciator. It is called autopilot enunciator. Then we have the selected height. Here it will be shown some numbers and this will show the selected height. We have here the flight director. This area is a flight director, this display. Then here you have the vertical speed, vertical rate of climb. Then we have here biro height, vertical tape scale. Here if you see this one and this one, it is a vertical height. Biro set, you can set the barometer. Here we have the Mach number indicator 0.533. Here we have the heading scale here. This you can see here. Here we can see attitude attitude ball. It will show the attitude here. Then we have airspeed, outer pointer scale. Here it will be displaying the airspeed of the aircraft. And this is the selected speed. At what? In this time you can see that 340 means presently aircraft is flying at 340 kilometers per hour or knots. Here is DME 10.9. So this I have shown a small the view of this display. I think it is clear now. So this is the description of the second generation modified display system. Further, second generation, we have some more detail I want to show you here. And you should know that nowadays most of the aircrafts, they are in the second generation, and 70% of the total cost goes towards this avionic systems. And this makes aircraft very safe and flight very comfortable. Here I am displaying you the two types of aircraft, modern aircraft. One is the Airbus 380 and another is the Boeing 787. Both are very well reputed aircraft, and they have equipments little difference from each other. They also appear different in different conditions. So here ECAM Airbus 380. So if you see here ECAM is what? EICAS and EICAS. What is EICAS? It is a electronic indicating and crew alerting system. And the same thing is called the electronic crew alerting and management system. Airbus 380. It has got the 6 displays, 2 primary flight displays, 2 navigation displays, 2 ECAM displays. And if you see the Boeing 787, this was developed 2011 and this is 2007. Here we have the CTOM AM LCD is 15.1 inch. Okay, we have the single PFD. Here we have the 2 PFD, but in this aircraft in Boeing we have the single PFD. 18 replaceable units, 2 head-up display. Here just you can see, here we have the head-up display. For each pilot we have the head-up display, but here 2 ECAM displays are there. Controls and handling similar to previous aircraft. Here this you can see the Boeing 787. It contains head-up display, 5 large area 15.1 inch diagonal multifunctional split screen display. So here this one, they are the multifunctional screen display. Conventional yaw control. Here it is a conventional. In Boeing it is conventional, but in Airbus it is a stick. Very simple. So there is a little difference between this Boeing and the Airbus. So this you can see here that Airbus do not have that yoke. Airbus has got one stick here. These are the stick, control stick, and they have all the switches. If you operate, it will move. So if you talk about this Airbus 380, very huge aircraft. In this, if you see here, the integrated standby instrument, then 6 into 8 inch rectangular portrait oriented EFIS ECAM. Here 1, 2 and the 3. Then we have here electronic flight bag is here. In that all type of documents electronically it is stored. Side stick control, 2 FMS displays. Here 2 FMS, one is this, another is this. Cursor control. This you can, like your laptop or the computer, you can control and it can work like this. So this is a very brief idea of the 2 major aircraft of the passenger or the commercial aircraft used for the different purposes. Now we are in the next gen, very modern, and these aircrafts also have started working in modern aircraft. So here what is the necessity of going so beautiful? This you can see here. Your screen, your sky, everything will be visible, and very few equipments, just like you are watching a TV. Okay, like that type of nowadays in the next generation it has been developed. So what is the aim of this? Is crew centric. It is a crew centric, means the pilot or the any other crew who are, this is depend upon their thought, their thinking, how much they should have the comfort, so that they can concentrate on some safety issues, not only this operation and this visual. Everything will be visible on their screen. Popping window and head-up display. So here you will have the popping window and head-up display. Touch screen interface. Touch screen interfaces are there. Direct voice command, and this will be developed by 2030. Like this cockpit you are going to get very soon. Maybe 4, 5 years or 6 years you are going to get such type of displays on the most of the modern aircraft. One display for a cockpit. This is called Interactive Solution, ODICIS by Thales. This is the name of the company, and they are able to make this type of systems. So I will start from the bottom. Here we have the primary flight display, navigation display, ECAM, FMS. In one thing you have here, only one item you will get all what you will see. Touch screen is here. Single contiguous large area wrapped around instrument panel. Here, this is. Then on the screen or on the cockpit glass, you will get cultural feature, the cities and all. You will get here wide angle color head-up display. Here, this is the head-up display. Here you will see all this rolling, yawing, pitching, all type of motion of the aircraft is visible here. It is called wide range head-up display. Pathway in the sky. In the sky you will get just like a road. You are walking on the road, or you are driving your car on the road. That type of feeling you will get it. Then EFVS, TAWS, synthetic vision image. Here you will get some vision image. Your any clouds, any things are there accordingly. As per this, it will indicate that there is some cloud, something. These all things will be visible on your screen. You need not to see below. Everything is on top of your system. So this is the next generation. Mostly we are going to get like this very soon. In 4 to 5 years, we are in middle of the 2020, 22, and within 4 or 5 years we are going to get this type of cockpit in most of our commercial new aircraft, which are going to come in after 4 to 5 years. So as of now, I have done with my avionics systems. As I have indicated, my topic is avionics and the mission system. So now I will proceed with my mission system. So in aircraft, if you see here that aircraft, the systems can be divided into airframe, structural system, vehicle system, avionics system, mission system. So this just now I have completed, and this I am going to complete now. This is the area which I am going to take. This I have already done, this I have already done, this I have already done. So if you see here, the mission system, it contains sensors, mission computing, and the weapons. Okay, sensors, we need the sensor for mission system, we need some computer, and we need some weapons like missiles, bombs, torpedoes, other different ammunitions and all. So we need like this. So I will start the mission system. In this, first we will start with sensors. What type of sensors and why it is required? Because nowadays, every mission, if you are flying 10 kilometers away and you want to detect something on earth or in sea or especially underwater, how you are going to observe, how you will monitor that anything is there inside the sea. So we need some sensors, and those sensors are used to detect the objective for which your aircraft is designed. So we need some sensors. These sensing in a modern civil aircrafts, I am talking about only the civil aircraft, air data sensors are required, magnetic sensing data are required, inertial sensing data are required, integrated system data are required, radar sensors are also required. Each family owns attribute and the strength. So this type of data has got own pros and the cons. Some are good in one area, another is good in another area. Another is not good in another area, someone is better in that area. So we have to use, as per our mission, we have to use different types of air data system. We may have to use the magnetic sensing data, inertial sensing data, integrated systems data, radar sensors, and so on. So modern integrated systems have the high accuracy. If you see the GPS also, nowadays they can measure in inches. Okay, so blending information from multiple sensors. So these different sensors and many more are joining together, and there is a computer. That computer is finding out the best solution, and that best solution will have the high accurate result. So that is the objective of this mission, sensors. So here I will talk about the mission system. Only the sensors I will talk here. That is the air sensor which are operated. Mostly we take the pitot tube for this. Temperature we take the thermometer. Pressure also we take. All different things are here. So if you see here, air data parameters, we need the pressure and we need the temperature. This pressure and the temperature are the primary data, and from this pressure we can find out the altitude, we can find out the indicated airspeed, we can find out the vertical speed, Mach number, SAT, TAT. These all things can be find out from this. Like this, if you see about icing risk and all, if you see here the pitot tube, we have here pitot static prop, here we have the airflow, we have the pitot tube here, we have the static, this is the static tube here, and here is coming, and here we have the aircraft skin here, we have the heater here, we have to provide the heater, this is the heater, this heater will heat it, otherwise this hole will be blocked. Pitot pressure is observed here in this point, and static is observed in this point. So here if you want only static port, then a small hole is made and static pressure is measured on the skin itself. If you see here, aircraft skin is here, TAT data, sensing elements are here, air is entering here, and from here it is leaving, and in this way we can get the pressure difference or the temperature difference, and these pressure and the difference is converted to the electrical signal, and these electrical signals are displayed on the cockpit. So this is the air sensors. By air itself we can get these all parameters. Now another type of sensors we have, that is called the flow sensors, liquid level sensors, pressure sensors. So if you talk about the flow sensors, these sense the amount of lubricating oil and the liquid coolant in motion, as well as fluid moving in fuel transfer, and the bleed air temperature. So flow of fluid, flow of the fuel, flow of the oil, flow of the hydraulic fluid, how much it is flowing, that we have to measure, and these things are measured by the flow sensors. Liquid level sensors. If you take the oil tank, fuel tank, hydraulic fuel tank, how much water reservoir or any type of sumps which are used to collect the oil and the fluid, that has to be leveled. So this monitor the oil, fuel and the coolant level, as well as fluid levels in potable and the grey wastewater reservoir, collection sumps and hydraulic reservoirs. Next is the pressure sensors. These sensors are monitored pressure in hydraulic system, including those used for moving control surfaces, braking and raising and lowering the landing gears. Next is the position sensors. In the position sensors, we have the linear variable differential transformer. It is LVDT. If you want to measure the linear distance, then we will use the linear variable. And if you want the rotation, like rotation of your aircraft, rotation of your control surfaces, that time we use the rotary variable differential RVDT. So LVDT and RVDT, these are the position sensors. Like your jack has to move like this. So how much it is moved? These sensors will indicate that what is the position of your jack. So like this we have to, the sensors are used on the aircraft. Now temperature sensors. So how these temperature sensors are working and how it is used. So temperature sensors play a key role in monitoring the condition of hydraulic oils, fuels and the refrigerants, as well as temperatures in environmental cooling system. So here we want your oil is going inside the engine, it is lubricating and the cooling the bearings of the very hot zone. This has to return back, and after this returning it has to go to the again tank. So it has to be cooled. So the temperature sensors are there, up to what level we have to cool and what is the maximum temperature in which the oil is working. These all things to be monitored, and this has the temperature sensors are the equipments which senses and deflected on the pilot's display. So now types of temperature sensors, we include the biometallic temperature gauges normally used for the engine temperature, electrical resistance thermometer such as Wheatstone bridge indicator and the ratio meter indicators and thermocouple temperature indicators. So these are the few types of temperature sensors. Mostly we use the thermocouples, consist of two different metals contacting at separate junctions. The temperature difference in the metal produces a voltage proportional to that temperature. So by that this temperature is converted to the voltage. Two different types of materials are joined, and if it is put at the temperature, there will be a difference in the voltage. That voltage is measured, and that voltage will be the directly proportional to the temperature of the particular point. So that is the principle of the thermocouples, and mostly in engines, to measure the temperature of the engine, we use the thermocouples, because thermocouples are the metal type of sensors and they can measure a very high temperature as per the engine requirement. Now about the air sensors, air systems, a petard probe on the fuselage. It is shown here in this diagram. If you see, this is the reference I am writing here, reference 2. So petard static system, the petard static pressure system provide the source pressure for a variety of aircraft instruments, including airspeed indicator, vertical speed indicator and the altimeter. So for ASI, for VS and for ALT, these are the petard static tubes are used. Petard static system gather two air pressures from the separate port. One is the static pressure and another is the dynamic pressure. The petard tube collects impact air pressure, measuring the full force of air as the aircraft moves forward through the atmosphere, while the static port gathers static air pressure, represents the atmospheric pressure outside the airplane in still condition. So the static pressure is the atmospheric pressure. At that condition, it is measured by the static pressure. So now we will have the air data computers. So aircraft with a digital instrument system receives data from various sensors. air data computers process the input from these sensors, apply compensating factors and present information on flight display to the pilot. The electrical output from analog sensors must be pre-processed by analog to digital converter, while the digital output of the solid state sensor can be handled directly by the computer. Air data computers compensate for factors such as very low ambient air temperature and air density variation due to the compressibility of air at high speed. They also output data to variety of aircraft systems, including the transponder, fuel temperature indicator, flight director system, flight management computer, autopilot system, and inertial reference unit, and the flight recorder. So they are also output of the variety of the aircraft systems like transponder, fuel temperature indicator, flight director, flight management, autopilots, inertial reference system. These are also used by the air data computers. Now the next type of sensors are magnetic sensors. We have discussed about air sensors. Now how the magnetic sensors are used. You know that like mad. If one aircraft is flying and they have got the one magnetic equipments, and if it is near the sea, there is a submarine inside the sea. So if they are transmitting that magnetic wave, and if any metallic part is there, especially the ferrous material is available, the magnetic poles or the magnetic waves, the field of the magnetic will be changed. So that is the principle of any magnetic sensors. So just we can see here that here we have the magnetic detector. It is called the flux valve. This is the magnetic heading. This will go to the magnetic heading and the reference system. Here we have the directional gyro. Here we have to go the inertial heading. So here the magnetic heading and this is the inertial heading. This will go here. From here it will go to the aircraft heading. Here we have the radio navigation aid, and here we have the radio magnetic indicator. It will go from here. It will go to the aircraft heading, and here it will go horizontal situation indicator, and here the heading panel, and here it is shown the earth magnetic field. So if there is nothing nearby, then it will be like this. If any object is present in some range, this will be disturbed. Okay, so that is the principle of any magnetic detection system. Now, inertial system, this we can see that most of the navigation systems are working under the inertial systems, and in inertial system we get the acceleration. From acceleration we can get the velocity. From the velocity we can get the distance. So in this way we can measure how much it is working. So here we have the position gyroscope. It will give the distance, then it will give the velocity, and it will give the acceleration. So these are the position gyroscopes, rate gyroscopes, and accelerometer. This accelerometer will give the acceleration, rate gyros will give the velocity, and the position gyros will give the distance, how much it is traveled and how much it is remaining. So now how it is working, this we can see it is a gyroscope inertial system. So in all the X, Y and Z, this they are free to move in all the 6 degrees of freedom. Here we have the outer gimbal, we have the center, and we have the inner. So 1, 2 and 3. This is the 1, this is the 2, and this is the 3. So if you move this in this direction, other will also move in the different X, Y and Z. This you can see direction of the spin. Then arrow B, here it is Z axis. So it is a simple working principle of preservation of spatial system gimbaling systems. This is shown here in this way. Then inertial sensors further. how it is working? Measure acceleration along a particular axis. So 0 to t a into dt. This you will get the velocity, that is velocity is derived data. Senses force on a loosely suspended mass. So this will sense the force, and force is equal to mass into acceleration. Mass we know, so we can find out how much is the acceleration. And here we have the pendulum force, feedback, accelerometer. These things are here. So in this we will get, this accelerometer will measure the acceleration, and input axis, excitation coil, tick off, and excitation coil. So here we will get direct acceleration, and this acceleration A will convert into the velocity if you multiply it by the time, and further if you multiply further the time, you are going to get the displacement. Then radar systems, radar sensors are there, and these radar sensors are mostly by the electromagnetic waves. So here if you see radar altimeter, it gives the altitude with respect to the terrain. That is the benefit of this thing, because other, if you see the barometric altitude, this will give from the sea level, as you can see. But if the radar is here, radar will give from the location how much, this height will also it will show. Here also it will show from here to here. Here it will show. But if you use this one only, it will not give the from where you are flying. It will give from the sea level. So that we have to take care of. So radar altimeter, it gives the altitude with respect to the terrain. If it is a hill, it will show from the top of the hill. Baro altimeter, altitude with respect to the sea level, it is shown here. Frequency modulated continuous wave, FMCW, is common radar altitude. The frequency of this thing is 4250 to 4350 megahertz range, varies from aircraft to aircraft. This frequency may vary from aircraft to aircraft, because for military aircrafts they keep the secret. We should not think that at what frequency they are using. Altitude is measured from the time delay between the transmitted and the received signal. So how we can measure if it is transmitted, how much distance, and it is coming back. So accordingly, we can find out what is the height of this from aircraft to the given terrain by using the radar system. These are calibrated for installation delay, and these radar systems are also calibrated how much delay or any error in the system it is to be calibrated, and then only it is displayed. Now mission system, the radar sensors, I am further moving. A limited version of mapping radar enables navigation through cloud and storms, display in a weather radar display, Doppler processing for turbulence ahead, most useful during wind shear. So like this weather radars are here. This weather radar will display the weather condition. Mapping enables navigation through cloud and storm. If any cloud is here like this, it will show. If any storm is there, any rain is there, this will be displaying in this screen. Display in weather radar. Doppler processing is used. Mapping radar, it shaped beam to paint the terrain. Fixed depression angle, this you can see. Okay, this is the angle here. Illustrate terrain in terrain avoidance mode. So if terrain is there, it will also show how much distance some disturbance is there, any cloud is there, any rain is there. Even disturbance is a high wind, also it can be measured. Aircraft system design, how we can do a system design. So here we can see that structural system, aircraft systems, and avionics. This is called the total aircraft. So all the three component has to be merged, and then only a system design will take place. So here we can see that mission requirement. In this, what are the mission requirement? Payload, speed and the range of the aircraft, operating cost. This customer's requirement is this: how much load it want to carry, what speed and how much distance the customer want, and operating cost. What is the cost in which we have to manufacture the aircraft? So it will go for the aircraft design. In aircraft design, we have the mandated regulations, safety and airworthiness. The regulations as per India DGCA, as per the US it is FAA, as per international it is ICAO. And then structural weight and the size the designer will decide. Aerodynamic analysis will be done by the engineers. Engines, how much and what power of engine is required. Then after that we need this system requirements. In that we have the technology selection, GACS course, system, structures and the PowerPoint. These things are made. Aircraft system design, if you talk about the function, the performance, integrity, reliability, dispatch, availability, maintainability, support and the life cycle. So here we can divide into the two groups. One is the safety, another is the economics. So this aircraft should be safe and it should be also less expenditure. We should try to put on that system. Now, these are the some system codes. We have the green system, blue systems and the yellow systems. So in the green systems, nose, wheel, steering, landing gear, slides and flaps, reverser, engine 1, norm brakes, yam damper, radar, stabilizer, left elevator, right spoilers, right slats, right flap, left slat, left aileron and left spoilers are working by the green system of hydraulic. And then blue systems, it is emergency generator, slides, rudder, flaps, left and the right wing, slats, left and the right wings, left and the right elevator, left and the right spoilers, left and the right ailerons. They are the blue system is emergency. It is working by the emergency generator. Yellow systems, flaps, alternate, park brakes, reverser, engine 2, yaw damper 2, radar, stabilizer, right elevator, left and the right spoiler, right spoilers, left flap, and these things are working with the help of yellow system. These are the references. Moir I and the Seabridge, aircraft systems, mechanical, electrical and avionics system, professional engineering publishing limited, London, and Moir and the Seabridge, the next book, design and development of aircraft system and introduction, AIA education series. Any questions you are welcome to ask. I will also request to subscribe and like this channel, give the comment so that I can improve in my channel. This is my email. You can send email to me. I will reply your queries if any. Thank you very much for joining this, and I am ending here. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.